Residue we will see hereafter. Residue, this is just can tell, this is also one complex integration. When any integration, complex integration, integral value can't find, then we can take help from residue. And no need help. Every complex integration, we can find solution, integration of f of z dz by the help of residue. This is just one thing, complex integration, one method, and very good method. Maybe complex integration solution we can find by the help of Cauchy's theorem, by the help of Cauchy's integral formula and all. So that and all sometimes very tough, lengthy calculating going on. But this is a very easy method, very easy, very easy. Every integral complex integration we can find solution by the help of residue. Some books and all writing also calculus of residue, like this name they are giving, chapter name. One question from singularity pole and all, one question from residue, one question from conformal mapping, and another one question from that analytic starting some chapters and all. Differentiability, continuity, that I fix have this question and all. Part B like that one question, part C like that one question. Finished. So residue of f of z at isolated singular point. Residue finding means isolated singular point. Either essential also no problem, but non-isolated no. Isolated singular point at z is equal to a. Then residue of f of z at z is equal to a is, this is the just definition. 1 by 2 pi I integration contour C, this is fz dz. So is equal to a, isolated singular point lies within contour C. Always residue at which point we will find the singular point must have inside domain. Okay, inside domain. So finally, okay, this is the formula, but our target residue, in residue our target no integration value how to find. Residue finding that is different, but integration value our target how to find, because more function will give on exam hall like that, find integration f z dz. We will think complex integration, different concepts. From complex integration they will ask along x-axis, along y-axis, then only you write answer. Otherwise normally integration f z dz asking, you go by residue. So residue chapter, this is the target how to find complex integration value on contour C. Okay, so just you think integration C f z dz 2 pi I into residue of f of z at z is equal to a. This is the formula. But how to find residue hereafter? So residue is the denoted by a minus 1, coefficient minus 1. And what is this a minus 1? Any place you saw this a minus 1? Principal part. Where? Laurent series. Laurent series principal part, coefficient of 1 by z minus a. So 1 by z minus a coefficient, whatever will come, that is the residue always. So a minus 1 is the coefficient of 1 by z minus a. So we can find there and we can put here means integral value we can find. So residue we have to find. First method, just you think Laurent series. Or just expression. Laurent series, if sometime fear coming by name, leave it. Just we can make binomial expression we can use. And whatever 1 by z minus a coefficient will come, that is the residue of f of z at z is equal to a. Okay. Another method also we will see, because sometime big series and all, or big function and all, we can't make binomial expression, we can't use, we can't expand them. So we can go by this some formula and all. So residue we will see based on some formula. Okay. 1 minute. Huh? So when we have pole of order n, this formula based on pole only. But residue we can find isolated singular point, either essential also. If suppose essential, then you go by binomial expression, just 1 by z minus a coefficient a minus 1. That is the residue. But if you are getting pole and you can't expand, we can't do binomial expression and more lengthy will go. So direct we can go by pole concepts. When pole of order and have, by this formula we will go. This is also a minus 1 only. All are. If when binomial expression we will use, no, so by this formula whatever will come, this is the coefficient of that 1 by z minus a. Don't think this is the other formulas or other concepts. No, residue means coefficient of 1 by z minus a, where a is a singular point, isolated singular point within contour C. Always have to contour C inside. Within lies contour C. Okay. So by formula go or by binomial expression go, that coefficient value only will come a minus 1. And this a minus 1, this a minus 1 don't match. This is a notation, so a minus 1. No, a minus 1 is the coefficient of 1 by z minus a. Either any singular point name. Okay. We will see hereafter. Another one thing. Residue we are going to use for integral value. So just now I gave definition, integration f z dz is equal to residue 2 pi I into residue of f of z at z is equal to a. But sometime you will see that more than one singular point is there. Anyhow, one singular point or two singular point or anything. Residue we have to find for every singular point, separate. But how to find integral value? That also we will see after that question. When simple pole of order 1, direct we can use this formula itself. From here and 1 minus 1 0, no derivative, direct z minus a into f of z for simple pole. Writing on this a minus 1, write every places. Huh? Within contour C, which singular point on domain outside have is no need to use, that is not analytic point, not a singular point. On also have no residue. Whatever inside have, that only we will focus, and by that only integral value also we will find. Here what we will do, all residues we will find for every points and just we will add. Right. What is the residue at z is equal to 0? What? 1. Direct one till coefficient of 1 by z. Here z is equal to 0 is a isolated pole also. Direct pole, right? Otherwise, or isolated singular point, right? No problem. So residue, we will find residue of f of z at z is equal to 0. Coefficient of 1 by z minus a. What is the coefficient? 1. 1 by z, 2 by z I will give 2, 3 by z I will give 3. Okay. You will go by formula. You can find direct by formula also. Suppose I will give 2 by z minus anything, 3 plus 2 square by z minus 3 whole square, like that going on. What is the residue at singular point? Minus 2. Minus 2. Here we can write z is equal to 3 is a isolated singular point. Either infinite going or not going. This is, if finite also I will choose, this is the residue. So residue of f of z at z is equal to 3. Coefficient of 1 by z minus 3. So minus 2. Sin z. What is the residue? 1. How? Huh? 0. Where is coefficient of 1 by z minus a? Analytic function. No residue. If binomial expression also all are analytic part. If we will go z minus z, what is formula? Factorial 3 like that going on. Analytic part. No principal part. So no a minus 1. So residue of f of z at what? Nothing. No singularity is here. So residue, just you think residue of analytic function. 0. One theorem also have. Residue of analytic function, removable singularity function, residue is 0. Sin 1 by z. Binomial expression to x minus x cube by factorial 3 like that. What is the coefficient of 1 by z? So residue is 1. So residue of f of z at z is equal to 0. 1. Understood? Any function have, if you are feeling binomial expression is easy for me, just put expression either finite or infinite going. Coefficient of 1 by z minus a. Two. We'll see sin x binomial expression, cos x binomial expression, like that. Victory sign giving his. So coefficient of 1 by z 1. So residue of f of z at z is equal to 0 1. Hurry, don't do an example. This is our mistake. Here 1 by z, here 1 by z 2. And they will give first option 2. Next question. This only we are doing on example mistake. No harbad. Cool. Always cool. Everything will pass. Right? Now fz I choose. Only they will ask residue, then direct residue find. But integration of f of z dz means c must be need. Okay. Suppose if I will choose r is equal to 1.5. Wait. Otherwise, no. Integral later we will think. First we will find residue. We know that in this case, no, whenever polynomial form like this given have, direct we can tell power 2 means 1 is the isolated singular point with order 2. Means power 1 is a pole of order 2, 2 is a simple pole. Like that we will tell. So first we will find residue and all, after that integral we will see. Depend on R. So first we will find at 1. So order 2 have means 1 by 2 minus 1. We will go by formula 1 by 2 minus 1. Limit z tends to 1. After the derivative n minus 1. So here 2 have means first derivative only. After the z minus 1 whole square into f of z. This is the formula. This is normal one only. So just we will do derivative of 1 by z minus 2. Single derivative. So I think minus 1 z minus 2. Correct? Here after limit we will put. So here 1 we will put means anyhow minus 1 will come. Next, simple pole. So residue of f of z at z is equal to 2. Simple pole is there. So direct formula into f of z. This limit we will put here means anyhow 1 coming. So if only residue asking on singular point, we can find like that and we can check it. Here after we have to find integration value. So just think case first. If r is equal to 1, then what is the integrable value? Zero. Very good. When r is equal to 1 I am choosing, then this does not lies. This is on boundary is there. So residue fell. Residue can't find. So integration value 2 pi I into means no residue. So 0. Case 2. You can write here the no residue. If r is equal to just greater than 1, 1.5, 1.2, 1.3, anything. Less than 2 also take. Otherwise like that you write. 1 less than r, less than 2. Then what is the integration f of z dz? 2 pi I into, only we will find residue at 1. Residue at 1. At 2, no need to find. So here we can write residue of f of z at z is equal to 1. So 2 pi I into minus 1. So minus 2 pi I. I have no place. First you write. Exam, mostly chance have hereafter exam will happen on Jan last. No December. Jan last. 26, 27, 28. 90%. After some days, 99% I will tell. 90% chance hereafter Jan last only will happen. And hereafter they will follow like this. Jan last this season and June exam on July. July last. December hereafter very rare chance. October finished no mostly. Then still application form not giving no their date. October last, November first week, second week they will tell application form. But hereafter don't expect your cutoff will be like this only. General cutoff will go 115, 120 always for JRF, 110, 17 for net. EWS cutoff will be 100 means 95, 105 and OBC cutoff must 90 will go hereafter 90 and 90, 100, 90, 100 like this. Must either paper is easy or tough. 2-3 marks up down will happen hereafter, but before type 84 net 94 JRF like that. Because of this PhD. Now PhD cutoff they are giving. PhD is Finished. Here itself, suppose case third, if r is equal to 2, then integration value what will come? 2 pi I into residue of f of z at z is equal to 1 only, because 2 is the boundary. So 2 pi I into minus 1 minus 2 pi I. Case 4, if greater than 2, r is greater than 2, then we can write here both 2 pi I into residue of f of z at z is equal to 1 plus residue of f of z at z is equal to 2. So 2 pi I into minus 1 plus 1, 0. Okay. So any function given have integration value asking, you can go with residue. So any integration they are defining, direct go by residue. Suppose they will tell integration sin z dz. What will happen? Cos z. Minus cos z. My all hard work fell. Integration sin z by z. Integration cos z dz. Integration z dz. சொல்லுமா Analytic function, no? What is the residue here? No singular point. 2 pi into residue point, no? This is the removable singularity. Removable singularity means one type of indirectly can tell analytic function only. We can remove singularity and we can make analytic function. So anyhow, no coefficient of 1 minus z, 1 by z, no coefficient, no singularity, analytic portion. Analytic part integration is no residue, so 0, 0, 0, 0, 0. Also contour define have. Contour, C is a contour. Anything, any contour they will give, analytic function. Especially they are giving any limit, they are giving 0 to 1, 2 to the, then you try by z square by 2 or limit put or along x axis go, along y axis go. If normally C writing, then don't go by formula z square by 2. After that, z what will happen? Will fly z. Here this is depend on C, everything will happen. When function is, what is going on? Today mind is completely here, not have after lunch. What happened? Before lunch, any good lunch came, more happy after lunch. Then suddenly another topic going on. When function is analytic, analytic means no singular point is there, then how residue we can discuss. So direct time residue writing 0 means no residue, that is the meaning. So integral value 0. Same for removable singularity. At z is equal to a, then also this meaning this is analytic only. We can change in analytic function, so no residue. So here also I can write residue of f of z at z is equal to a is 0. But here that also we can't write. Anyhow, this type integration on that contour, integration will be 0. Okay, right. So any type of function have integration they are asking, you go by residue find and depend on domain how many singularities inside there, all residue find just addition to multiplication with 2 pi I, that is the integrable value. Some theorem have, by that also we can go. So this theorems also coming by formula only. By normal formula you solve, same answer will come. So when we have f of z simple pole at z is equal to a, and g of z is analytic at z is equal to a, and g of a not equal to 0, then residue of multiple function f of z into g of z at z is equal to a will be, this is the g of a here direct right, into residue of f of z at z is equal to a. Simple pole formula. Okay. When function is analytic at, now divide, we will go fz by g of z. So here function is analytic at z is equal to a, and f of a not equal to 0. Here g of z, z is equal to a simple 0. A is a root of g of z, denominator function. Means a is a singular point of complete function. So g of a is equal to 0 and a simple 0, so first derivative is non-zero. So direct residue formula f of a by first derivative, after that means g dash of a. Direct we can use. Last exam only, this formula direct they ask on option. This theorem itself. Sometimes this f of z is not there. Only sometime you will get like this. Same everything, residue of 1 by g of z at z is equal to a. Means just you think a is the root of g of z, simple root, then what is the residue? Direct 1 by g dash a. Same by that formula only will come. When limit z tends to a, we will do, same will come. So 1 by g dash of a. Suppose fz is 1 by sin z, or maybe they will give find integrable value also. They will give like this. Domain D, they will define. So anyhow, integral later we will see. First, this is the function, and we will find residues and all, where possibility residue. So residue where possible at isolated singular point, and isolated singular point means zeroth point of sin z, denominator function n pi. So residue here possibility. So if suppose I am finding residue of f of z at z is equal to n pi for all n natural integer respectively, I am going by our common formula, and all are simple zeros, simple pole. I can write this is simple pole respectively for all n. All are simple. Simple means direct formula. Z tends to n pi, z minus n pi into sin 1 by sin z. For every n pi, this is for every discussion going on. So 0 by 0 form will come. This is so L hospital rule we will use. This is the derivative 1 cos z. So 1 by cos n pi means minus 1 power n anyhow will come. This is the residue. Okay. One formula also I gave, theorem, last theorem, 1 by g of z. 1 by g of z I gave, no? G of z, there g of z, this is the 0. So direct 1 by g dash of a. This much in between don't want. That also we can apply. Understand if theorems and all. Okay, if residue asking, this is enough. If they will ask 2 pi, 3 pi, anything tell, I gave generalization. Here after integration value we will think. So suppose integration value giving means domain value must we need. What is the domain? Suppose the domain I will choose Z, center is 0, 0, radius is 10. So integration of f of z dz is equal to 2 pi I into residue of f of z at n pi. And that n pi, how many n pi inside domain containing, that only we can choose residue, otherwise no. So 10 means what will happen? Just you think minus 10 to 10, pi will come. Suppose this is pi, 2 pi, 3 pi. Same, minus pi, minus 2 pi, minus 3 pi. 4 pi and all not possible. Means 3 point here, 3 point here. 6 point will come. Means here we will write 2 pi I into residue of f of z at z is equal to n pi. Here summation n is equal to otherwise here I write and only summation right enough. Just we have to add all n pi. Pi 2 pi 3 pi minus pi 2 pi 3 pi. Tell me here after. 0. 0 why we have to count? Our singular point is n pi, no? Oh, n equal to 0 also have, no? Correct. 0 also we can count. Only I'm thinking pi. Then total 7 points coming. 3, 3, 6, 7 point. Okay. So first tell at z is equal to 0. So minus 1 power 0 means 1 only. Next at pi means n equal to 1 means minus 1. Next at 2 pi positive 1. Like that only will happen. 1 minus 1. So correctly have to write. Next 3 pi minus 1. Next minus pi. So minus 1 power minus 1 means anyhow minus 1 only. Minus 2 pi 1. Minus 3 pi minus 1. So just correctly like that you will do answer. This will cancel, this will cancel, this will cancel. Only minus 1 coming. Minus 2 pi I. Understanding? So this any mistake means answer change. So correctly do. And this type only coming on exam hall. Any problem? That is no problem in natural integer. Where n I used? Depend on something is there. Here you see, here integer, natural, both right, no problem. Another which place? When theta equal to 0, theta is equal to n pi have, that place, which place? Integer writing also no problem because minus 1 plus 1 only will come for that. No problem that is. You can change by your comfortable. That is no problem. But here integer only must write because we want point inside our domain. Here only natural will go, then you will go get 4 points only. Natural also not. Means 3 points. If 0 we are not counting means. Here must. Otherwise there also you change if you are getting confusion. No problem. That is just theta value. So for all integer you write. I was also thinking that is, but I neglected. Because that is common only. You also can change. But here must have to write. Okay, write this. Like this only question coming. Another any problem? What is the integrable value? Integrable answer. Domain is same, you can choose. Two pi I into residue of f of z at z is equal to 0. What is the coefficient of 1 by z? This much time by taking. Compared to real analysis integration, complex integration is easy. Only residue, 2 pi I into residue, finish. Suppose integration tan z dz, domain D. Domain D I will give, suppose center 0, radius is 10. Then zero. How? This is analytic function. Sin z by cos z, how analytic this is? This function you see, integration sin z by cos z function, no? Suppose I give, you can go by common formula or you can go by theorem. Our fz given have sin z by cos z. I give now fz by g of z one theorem. Suppose this is h of z name. This is f of z by g of z. I think I wrote this is analytic at a, means at which point this zeros points are analytic point, correct? So cos z is equal to 0, z is equal to 2n plus minus 1 pi by 2 for all n belongs to integer. So these points are zeros point for cos z and simple 0 also, correct? All are simple 0. G dash of z not equal to 0 will come at this point. Simple zeros for all, correct? Then residue what will come? Residue of f of z by g of z at z is equal to a. A means these points. At z is equal to 2n plus minus 1 pi by 2 for all n integer respectively. What will come? F of a by g dash of a. So here f of a means sine of this by derivative. What is the derivative? Cos z is minus sin z. I think same point. So minus 1. Correct. For all is same. F of a cos z is minus sin z derivative. We can write like this also. Suppose sin a by minus sin a. This only, no. What is a? For all a. This. For all a belongs to or equal to, right? For all a equal to 1 by 1, 2n plus minus 1 pi by 2. For all n belongs to integer respectively. Whatever a we will choose, we will put cancel. So minus 1. So here after we have to choose domain inside. Less than 10 have. Here after this only we'll repeat minus 1 1 minus 1 for all a. Whatever a we will put minus 1 1 means minus 1 minus 1 minus 1 for all a. So here what will come? 2n plus minus 1 pi by 2. How many points will come? N equal to 0 means pi by 2 will come. Pi by 2 will come only inside 10. Just 3 points something by 2, that is 1 point. Suppose this is minus 10 to 10. So we come, this is 0. Pi by 2 here will come. N equal to 2, 3 pi by 2. 3 pi by 2 also will come. N equal to 1 minute. N equal to 1 means 3 pi by 2, 2 means 5 pi by 2. 5 pi by 2. 5 pi by 2 also will come. N equal to 4, 3, 7 pi by 2. Will come, 7 pi by 2 also will come. After that, not possible. 0 will come any point? 0 won't come here. So can tell that here 4 points, opposite 4 points, 8 points will come. 0 won't come, any n 0 won't come. Won't come, greater than 10 going. Okay, won't come also, no problem. Huh? Won't come, no. So 336 points will come. So 6 times minus 1 minus 1 minus 1. So here no problem, direct integral we will go here after. So we will write here 2 pi I into 6 times minus 1 minus 1 minus 1 we can write. So 2 pi I into minus 6, so minus 12 pi I. Okay? Like that question will come. Right. I'm writing practice letter. Domain you also can choose whatever radius, center, domain you can choose and you can find yourself. Like that, more questions can prepare. Only find by residues, huh? Domain C you can decide. Hereafter we will see residue at z is equal to infinite. Residue, when we are finding finite points now, whatever we found, all are positive direction. That is anti-clockwise direction. All are positive direction. But when we are finding residue at infinite, no, positive direction. Sorry, negative direction, clockwise. In complex analysis, no, we can't prepare any image. We are writing the limit z tends to 0, z tends to 1, z tends to 2. So we can approach that point by anywhere. We can approach this point like this. We can approach this point like this. We can approach this point by any curve. This approach we can go by straight line. So going on. We can't give imagination. We can't prove by graph like this image going like the image going. No, any points. So what are we are doing now? How will explain? Suppose this is just you think this is our disk. Any center is 0, 0, radius is 1. So when we are finding residue at infinite, no, that we are doing this Diwali coming, no, crackers, Cherky, what telling Cherky in Tamil, English, I don't. Huh? Rotation giving, no. So that coming, no, lighting and all, like this only. So when this light just you think, no, outside rotation giving, no, then that is called a residue at infinite. And this all are like this, clockwise, negative direction, like this rotation giving. So outside we have to find concepts. When in mathematics, anti-clock means positive direction. For that, this notation is, but this, when this type rotation given have, then inside domain we are finding our residue, whatever points are there. This type rotation will give. Is that like this? That is the meaning. Different image are there, like this explanation are there. And very different. Residue at infinite and residue at finite points. So residue at infinite, no, just minus, negative. Means suppose if f of z has singularity, isolated, at z is equal to a, then when isolated singular point have, then we will find residue at this point. So just you think residue of f of z at z is equal to infinite plus residue of f of z at z is equal to a, their addition will be 0. Just negative direction, positive direction, residue, when addition going 0. Means residue of f of z at z is equal to infinite. This notation we are giving, no, a minus 1. So residue of f of z at z is equal to infinite is equal to, we will find residue at a, whatever singular point have, and just minus we will put. No new work. Formula is there, but by formula you will go, you have to mug up that formula, extra tension. No need to mug up. For single point, like this. If suppose more than one point have. So all residues we will find an addition and minus. Anything want to write this image and all? Just cracker, remember enough. Clockwise, anti-clockwise direction, enough. Suppose if more than one point, suppose a1, a2, ar. Lies within D or C, whatever name will give. Sometime gamma, alpha, any domain name giving, that is no matter. Within D, then Just we will add everything and minus we will put, that is the residue at infinite. Okay, right. So integration value on contour C with positive direction is anti-clockwise direction, a 2 pi I into residue at finite values. Whatever finite value means finite singular point. But if negative direction will go, the residue at infinite. Means whatever we are finding, just minus. Still integration that much not asking at infinite. Residue at infinite also not asking. But right. Just you think, if integration f of z dz given have and c given have, c normally given have positive direction only, have to think more deeply. If you want notation, then like this also they can give, and this is anti-clockwise direction, positive direction. So 2 pi I into, just now I gave single residue have, more than one have, then we can write sum of residues and all. This is already I gave. But integration C f of z dz, here minus sometime you will see. For that I told C means just positive direction. More places you will see minus C there itself giving, means negative direction. Or sometime you will see C writing, but here notation they will give like this, clockwise. So when this type integration want to find negative direction, then just 2 pi I into residue of f of z at z is equal to infinite. And this is equal to minus of this. So just minus multiplication we have to do. You can think like that. Minus of summation I is equal to 1 to r. Like this. Okay. Right. This side finish this and all. Finished? Suppose fz is z minus 1 into z minus 3 whole square. Then they will tell find residue of f of z at z is equal to infinite. Find everybody. Residue at infinite is nothing. Just normally find at singular point and just addition and minus. Finish. Doing or not? Just find residue at 1 and at 3. 0 coming. Addition itself 0 coming. Okay, then no problem. For me, what problem? What coming? That is the answer. Zero, everybody coming? So don't fear by at infinite residue. What is this? Just whatever singular point isolated have. Also sometimes suppose domain they will give. So inside the domain, whatever singularity containing, under that singularity residue find and just addition to and minus, that is the at infinite. Okay. And this is just formula. Just give, maybe we'll ask one example, means you can take out. But don't go by formula, unnecessary You have to change complete function in the form of 1 by z. In that 1 by z square multiplication I have to do. Then new function will get. That new function at 0, residue is and with multiplication minus. Then at infinite. So as a formula keep, otherwise don't want. If f of z is 1 plus 1 by z plus 1 by z square, then residue of f of z at z is equal to infinite, what is? Zero. What is residue of f of z at infinite definition? Minus of residue of f of z at singular point. Here singular point what? Here will come minus of residue of f of z at z is equal to 0. So what is f of z residue at z is equal to 0? 1. So this is minus 1. This much time will take. Here coefficient not given. Here after everything I will tell, then answer will come. Sir, 1, 1, 1, 1. Okay, try to catch soon. This is very easy. Argument principle we will see. From here this theorem, its statement. Watch want, that clock don't want. Want means I will take, I will give. Keep there itself. One clock, otherwise we'll put that place. Argument little only this is. Actually, integration, this is f dash z by f of z also any function only. So integration we can find by residue. But this theorem itself asking sometime. So giving. Ah, 2 pi I multiplication will come. So just here I am writing function is analytic in a simply connected domain D. Except finite number of poles. Means poles will be inside domain. Either D here I am writing, no, they are here not writing. Simply connected domain D. And D means also from C only, that is. Except finite number of poles means inside we will see that our poles are containing inside D. Then integration f dash z by f z dz C is any contour from D only 2 pi I into n minus p. N means total number of, means just addition of order of zeros of f of z. But zeros will lies from within C, not on also. Only within. Whatever inside containing, that only we will contain. Same P means sum of order of poles of f of z lies within C. Either poles or zero. Within whatever inside lies have, that only we will count. Okay. This statement itself means last time only asked, means last 1 year, two time exam happened. This statement itself asking. More time this formula asking. So this is regularly asking, so giving. Otherwise any integration of f z dz, this is any function only. Suppose they will give integration z minus 2 whole square by z minus 1 whole cube and z minus 3 dz. C they will give z. Suppose center 0 0, radius is 4, everything I am taking. Then they will tell find this value. So we can find by the help of residue also. But they will tell, especially integration scheme is no problem. They will tell find integration f dash z by f of z dz value. And this is the fz. Okay. Wait. Why I am writing 2 time integration? This is just if fz they will give. This is fz I am counting. If function anything they will give, and they will tell find this. This is the domain. So just we can go by derivative method and we can go by residue concept. So derivative will be lengthy process. This complete derivative we will do, lengthy process will go. So we can get from here. You see this is a function here, roots of fz is equal to 0 means we will get z is equal to 2. 2 time also. So z is equal to 2 lies here within C. 2 time no need to write, just write is a root lies within C of order. What will be the order? Order 2. So zeros came. Here 1 will be the pole and 3 will be the pole. Z is equal to 1 is a pole of order 3 and Z is equal to 3 is a pole of order 1 and both lies within C. Within C. Then hereafter integration value. Then integration C f dash z by f of z dz. Just 2 pi I into n minus p. N is just sum of order of zeros. Only one type of zero have and only one order, so 2 minus sum of order of poles. So 3 plus 1 means just 3 plus 1 like this. So 2 pi I into minus 2. So minus 4 pi I. This is the answer. If you will go by residue concept also same answer will come. Sometime asking good theorem this is. Right. can find by the residue concept, but you see we can find from here also. Cot z means cos z by sin z. So what is f of z? Sin z, because this is the derivative of sin z, correct? So f of z is equal to sin z. From here zeros, pole, whatever will come. So no pole. F of z has no pole. Zeros. Fz is equal to 0 means sin z is equal to 0, z is equal to n pi. And all are simple zeros, correct? Means order is 1, 1, 1, 1, 1. So what is the integration value? 2 pi I into sum of n minus p. So pole already not have, so n, 2 pi I into n only. So 2 pi I into sum of 0 of f of z. Order are 1, 1, 1. How many 1, 1 will happen? Domain. Minus 10 to 10 have, how many will come? 7 will come. So 7 times 1, 1, 1, 1, 1 will go. $14 pi I. Understood? So integration cot z dz 14 pi I. Purida naleke morning patmanike. The 10-13 Tamil what? Patra manike. Patra money have to tell. That is correct. Patra manike. Okay, tomorrow hereafter. Tomorrow we will see next one theorem after the next chapter.